Good evening, everyone. So today's topic is workshop, and we'll start from lathe. Then we'll go to the other workshop questions. Am I audible to everyone?
Yes, sir.
Please don't call me sir, bro. I'm also just learning. Okay
Okay,
then.
bhai.
Okay, bro. Okay then. Let's just start the first questions. So, what is a lathe machine? Anybody wants to answer? What is a lathe machine and the parts of a lathe machine? Anybody? Should I call by names? Besak, Octavia, Suhail. Who wants to answer the question? Gaurav.
Can I explain?
Yeah, yeah, yeah.
Lathe machine is a machine which used to remove the materials from a workpiece to give his desired shape and the length. That is called the lathe machine. That
Okay.
is okay.
Yeah, yeah. And can you explain the parts too?
Uh, in lathe parts, at first I am starting from lathe leg, and then the plate tray or chip pan, which is called the chip pan, then bed plate, and then carriage, headstock. In headstock, the headstock is a device where the gear mechanism will be fitted for giving the constant RPM of the spindle. And headstock will be fitted with spindle. No, spindle will fitted in headstock, and chuck will be over fitted over spindle, and it rotates. And in headstock, connected with the prime mover like motor or any motor or machineries, like who will give the prime move of that. That is, and tail stroke, dead center, ram clamp. Uh, Ram clamp is the fitted in the tail stroke. Hand wheel, uh, guide hoist, which is over guide hoist. The tail stroke will be fitted, and lead screw, uh, mm, uh, lead screw, uh, lead screw, feed rod. uh, उसके बाद एप्रॉन, एप्रॉन सैडल, compound rest, and compound or compound slide, mm, tool post, tool post holder, and gear mechanism. That is, sir.
So can you explain me the lead screw? What's the function of the lead screw?
Lead screw is a screw which is fitted the parallelly of the lathe, and it's one part side connected with the gear mechanism, which is connected with the spindle, and it gives a spindle gives when the spindle runs a constant RPM, this is same amount of, with a respect to a calculation there have a gear, a pinion will be fitted there in the lead screw, and which when we will engage this gear, it will be already rotate, and when we are required the continuous feed of the job, then we will lock this gear, and the feed will be automatically comes, and the when it will rotates, and when the half nut will be engaged in carriage, then carriage will be continuously feeded left side or right side. It is a gear mechanism. That is it.
Okay. And what is the function of the feed rod?
Feed rod is a rod which is parallelly fitted over the lead screw, and it is also connected with the main headstocks gear assembly. and from here it is used for mainly the thread cutting purpose. When we require the thread cutting, here a already predetermined value will be given there in the lathe, where from the setting will be doing before the cutting, which pitch will be required. There a reading will be given there, which position will be required. As per required, we give this position of the gearbox, and the a continuous feed rate will be comes from this lead screw to cutting the thread operation.
Anybody else wants to answer this part? Lead screw and feed rod. Anyone? Amston? Akhil Amston?
So I would say the lead screw is used mainly for the threading operation, wherein the carriage automatically moves to the left to the right for the thread cutting, so that accurately the threads could be cut. And also the feed rod is the rod wherein the carriage moves onto it. So this is the purpose of a lead screw and a feed rod on the lathe machine.
So if he's asking the function of the feed rod, we can just say that it moves the carriage, right? And while auto feeding, we use the lead screw, right?
Yes, yes, yes. For auto feeding it the lead screw.
Lead screw. Okay. Okay. And Gaurav, can you tell me what's the function of the tail stop?
Hello.
Yeah. Can you tell me what's the
Yes.
function of the tail stop?
Yes. Tail stroke is a component which is fitted on the lathe. It is used. It has a dead center fitted over its front side, and it is gives the uh, job as a support and gives the center of the job. It is and it transmits the vibration of the workpiece. That is
It transmits the vibration. I think it supports the workpiece so that it can be in a fixed position, right? And also it is used while drilling operations, correct? Like reaming, boring.
yeah. Boring and boring operation, drilling operation we can use on another as per required our drilling tool, or it can be fitted over here.
Okay. So what tool is required if we want to perform a drilling operation?
Yeah.
What
Can
tool
you
is required?
I not listen.
What tool is required? What tool is needed to be fitted with the with the tail stop so that the drilling operation can be done? We need to
Yes.
remove the dead center,
Yes.
right?
We at first we remove the dead center, and it will be fitted the drill bit to drill the workpiece. Drill bit will be fitted over here.
Drill bit is fitted with a part. I forgot the name. Amstel, do you remember the part in which the drill bit is fitted? Like it is fitted with the help of a chuck, but uh, the rotating part,
Tailstock spindle.
It is a
It is fitted in the tailstock spindle with the help
yeah,
of the ram clamp.
with the help of
So
the
you
ram
tight
clamp.
loosen the ram clamp, remove the
yes,
dead
it is
center.
a tapered cone type.
Okay. So the components of the dead center are ram clamp, hand wheel, and the
Tailstock.
tail stock, so that
Yes.
it can be locked, right?
Yes, yes. It has two hand wheels, so just one. I don't remember. It has only one, I guess.
It has, I think, one hand wheel and one ram clamp, correct?
Uh,
I think it has only one hand wheel at the bottom, at the back
yes,
side.
yes, yes. Only one.
Yes.
Yeah, yeah. Only one.
Yeah, yeah. So anybody else also wants to answer this question, or do you have any cross questions regarding the components of a lathe machine? So I'm going to ask the next question: how to align a tool in a lathe machine? Who would like to answer it?
Sir, in a three-jaw chuck or four-jaw chuck?
Uh, Tool. First, explain the tool that
That
is
is the
used.
workpiece. You
That is the
mount your
job.
workpiece. Yeah, that's the job to be done.
Yeah, yeah.
Workpiece.
First, can you explain me the tool? Then we will go to the job.
So the tool is mounted based on the operation to be done. Let's say facing has to be done. So a single cutting tool is it is selected. Then what we do is we change the angle of the compound slide onto the carriage as per the angle, and then we take it close to the workpiece. See for the centering whether it's properly aligned, whether the height is to the center of the workpiece, and then we tighten the tool post onto the compound slide, and then we start the giving the feed. So this is how the tool is installed, and then let's say facing has to be done. This is done in the following way.
While we are fixing the tool, we also use packing right at the top of the tool and at the bottom of the tool so that the tool won't vibrate or move out.
Yeah, I've seen packing. My sir was used to tell me that it was really for the height itself to get it to the center. So packing used for the vibration part.
Yeah.
I have no idea on it.
Okay. Okay. And while aligning the tool, we also used to align it with the help of the tailstock. We either carry the either move the carriage towards the tailstock or we bring the tailstock towards the carriage, right? Then we align the center before performing any drilling operations.
You get it to tailstock also. It
Yeah.
is saying only tool. So how is tool aligned in the lathe? So is it tailstock is required over here?
Yeah, I have seen a video, I think for drilling operations to so that we can drill it at the right center
But tool won't be used, no? Yeah. Correct. In case of drilling, the tool will be in the tailstock.
in
Okay.
the
Yeah.
tailstock. Yeah, yeah.
Yeah. Correct.
Correct. And then before drilling, we use a smaller bit. What was the name of the bit?
Twist drill.
Center drilling or something like that, right? If we don't directly drill it, right, with the
Yeah,
twist
twist
drill,
drill, no?
before
Twist
using
drill.
twist drill, we use something else, a smaller one,
To center it. Okay.
center drill, I think, to make a small hole.
Gaurav, you know anything about it?
Can anybody explain? We use a smaller drill so that a smaller hole can be made. Otherwise, if we are going to directly use this twist drill, the precision,
It's a
it may not be
multi-point cutting
precise.
tool. Yeah, it is a multi-point cutting tool. It can detect the center. So you use some kind of a centering tool wherein you detect the
Yes,
center, and then you use if it is correctly aligned. Then we use a twist tool.
yes.
Correct, na?
Correct. Yes. I'm just checking the word of it. Center drilling tool. First, we fit the center drilling tool, and then we change it with the twist drill. We'll go to the drilling part a little bit later on. And first,
Surprise, we can even use it dead center, right? It is also pointed. You can't use the
yeah.
dead center.
Yeah, we can also do it with the help of the dead center. Correct.
Okay.
So I think this is completed, right? To align a tool. Now we can move on to the alignment of the job. So let's go to the next question. How do we align a job in a lathe machine? Anybody wants to answer? Anybody? Octavio, Akhil, Harish Chandra? Yeah, please. Yeah.
In the chuck,
Yeah. First, explain in a three-jaw chuck. Harish?
Surprise, what is there in the question? IMS questions?
In IMS
Aligning of the
question,
job.
it was only tool.
Yeah. Okay.
So
This could be asked.
this
This
could be
could be
asked,
asked.
I
Yeah.
think, right? So
Yes,
I
yes,
just
yes, correct.
added this one, that job part.
Yeah, correct.
Anybody wants to answer?
first with the chuck key, you first align those jaws, and then you put the metal in it.
Okay, so in a three-jaw chuck, how to align a three-jaw chuck first? With the we keep the job in between, right? And then we use the chuck key. But to align the
Yes,
three chucks, what do we do? Yes, Gaurav?
yes. In three-jaw chuck is a universal chuck.
Yes.
Then that's why it's not required the another any maximum no another any process. It will be when we will tightening the key, it will automatically tighten from the each side, every side, and it will be comes in the center, and it catch the job as its center. That is called its universal chuck. It is only performed on for the cylindrical workpiece. And another, when the workpiece will be long in three-jaw chuck, then we can use the tailstock as for centering purpose. At first, we will tightening the chuck
We use the
between
gauge
put the
center.
workpiece and tightening the chuck, and then
Yes, yes. First,
yeah,
complete
yeah.
your answer. First, complete your
What?
answer.
Yes. Then tailstock will be comes forward and comes in the center of the workpiece, and from there it gives a support, and we rotate the spindle by the hand, and we see the any off center will be happen. Then we can tightening it more, and it will be
Gaurav, don't mention I would suggest not to
measuring
mention
by.
it dead center and all. Just mention how a three-jaw chuck works and a four-jaw chuck works, what part can be installed into it, and then it's enough. If you explain more, there could be more cross
Yes.
questions.
Hand or hammer, and then tighten it tightly. Then job will be started forward.
But it's better not to mention many things, right?
Is it hammered?
It's actually,
Safraj, you heard
we
it
don't
hammered?
use a hammer, but I remember we use a aluminum piece, circular piece, like not actually hammering, just put some pressure, like tuck, 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 just not with very high force.
Okay, okay,
I have
okay.
seen it just a
Yeah. Not very high force,
not with
only
a
for
very high force.
minimum. It is already a universal chuck. It will maximally 90% job will be true.
Aligned by
Then the
itself.
10% will be can be problem. Yeah, that will be measuring by the tailstock or the hammer. That is.
Correct. Can't we use a dial indicator or a center gauge for aligning the job in the three jaw chuck? Aligning the job in the three jaw chuck.
Yes, yes. We can do it.
We can, right? So, can you explain the functions like
Yes, we can do it.
how?
At first, we feed it.
First, explain the
Yes, at first we can feed the
surface.
compound, yeah, the dial gauge.
Yes,
Yes,
please.
the dial gauge will be at first fitted over the compound race. Then it, with respect to that, we move the job, and I will give a reading over the dial, and as per that we measuring the job where the problem which side. Then we will tightening it, and job will be true.
Okay. So, if you are using the dial indicator, then the arm of the dial indicator is connected with the chuck, right? Am I right? Then
Yeah.
there will be deflections in the
No. The arm of
meter.
the dial indicator, the dial indicator arm will not the connect to the chuck. It will be touch the job face, means
Okay.
job surface. It will be touch the job surface. When you rotating it, any side will be more or misalignment. Then it will gives a reading over here. The how much centimeter will be movement of the slide of the dial gauge. That's why we can, from there I can get the
That means after connecting the arm, we rotate the spindle, correct?
wrong.
We don't rotate the spindle.
Yes.
Okay, all right. And in a four-jaw chuck, anybody else also want to try?
Forjo sir.
Anybody?
Yes, you can try.
Yeah. If anybody else want to answer this question, then you
Akhil,
can. Otherwise, Gaurav will
please
continue.
explain.
Amston, he was right, right? Correct. He was correct, right?
About what?
about the centering of the three-jaw chuck.
Yes, but I would say it in a simple way, saying that you can the jaw moves like if you tighten it or loosen it, all the jaw moves simultaneously to each other. So like cylindrical parts can be put inside it,
Yeah.
and then you tighten, not tighten it fully. So a slight tightening is given, and then you rotate it with your hand, and then you tighten a little bit, then you start it, see if there is any wobbling or anything happening. If it doesn't wobble, then you can stop it and then again tighten it to the full, so that it doesn't come out. And then if it is wobbling, you can again rotate it into the jaw chuck by little loosening it, and then again you tighten it and then see if it is wobbling by starting. So this is how we were doing it. We did not use dial indicator
Yeah,
and all.
actually, I also have not used dial indicator, but I've seen center gauge, surface center gauge. Dial indicator is the similar kind of thing, but it's a little bit modern. So there is a meter fitted. So when the spindle rotates, if any fluctuations occurs, it shows in the meter. So I think no need to mention dial indicators, or should we mention center gauge, or no need? Just
If you
explain.
have used, you can mention like dial gauge without using it. Telling will be a risky thing. There could be cross question. So better telling what you one.
Santa Gauge. Just mention Santa Gauge because it's like we could see in many workshops that Santa Gauge is easily available. Dial indicator was is not easily available. So how to align a four jaw chuck? Anybody else wants to try? Akhil, Ayush, Tandel. Anybody wants to try? I think Gaurav, you
So
can.
it's a very tedious process, unlike the self-centering, that is three jaw. If you tighten one, all the jaw gets move towards the piece or move away from the piece. So this is a separate. You have to tight the individual jaws separately, like a square piece could be held inside the this jaws. Unlike the square piece can't be held into the three jaw chuck because it will not give a proper support. So we use a four jaw chuck wherein all the four faces we mount it into the jaw chuck individually, and then it's a very long process, time consuming. This is how I would say this.
And in Fojo Chuck also we can mention the center gauge, I think. Like if we one arm of the center gauge is connected with the job, correct? So when we rotate the spindle at a much lower RPM, we can see when the when the arm is not connected. So if there is space in between, so the side like four chucks are present at four different sides, correct? So
Yes, yes.
suppose the chuck which is in at the top, and towards that side the arm is not connected with the job. So first we will loosen that top part, and then we will tight the bottom chuck. Are you
Okay.
getting it? I'm not able to explain it properly, but are you getting it?
Can you show a figure or something? But you have worked on a four jaw chuck. You have worked with a four jaw chuck.
Yeah. But
Okay.
wait, I'll just try to find a figure.
Otherwise, we can do it at the last end of the meeting.
Yeah, sure. Like
That
it's
time
pretty
combination
simple.
all.
Four different chucks are there at four different sides, right?
Okay, yeah, got
And
it.
at the
Then,
middle the job is fitted, correct?
okay, yeah, yeah.
So one arm of the center gauge is connected with the job.
Okay,
So when we rotate the spindle,
yes,
and if the job is not fitted precisely, it's not at the
okay,
center, then we can see
okay,
that the arm is not connected with the job.
okay,
So
okay. So the
whichever,
arm should be connected exactly at the
exactly,
center.
yes, it should be
So how
connected.
you ensure that it is exactly at the center?
Yes, if it first suppose the top side, these are four different sides, okay?
Yeah, yeah, yeah.
And suppose the top chuck and towards his side there's a space. So what will you do? We will loosen up the nut, that is bolt that is fitted at the top.
Yeah.
So the the chuck will be loose, right? Then we'll tight it from the bottom.
Yes, yes.
I will just share the link of a video. It will be much easier.
Kamlesh, do you know how a four-jaw chuck works? Meaning the centering part, like
Alignment
if
of
you
a
install.
job in four-jaw chuck. Kamlesh?
Yeah, sorry, I was talking and I was on mute.
Yeah.
So I tried to find the answer, but couldn't find something satisfactory. They were like adjusting the jaws and tapping to make sure it's aligned, and they used that marking gauge, I think, what they called it,
Center gauge?
the needle type
Yeah, center gauge.
center gauge. Sorry.
And then how you
So
ensure that it is exactly at the center?
Wait, I will try to
uh,
get a picture. Kamlesh, you explain. I'm trying to find a picture of.
actually, I don't exactly know, but what I saw or like where they were doing it, like, uh, can you see my video? So let's say this is your job, and this is the center gauge. Okay, so this will be fitted inside the chuck, and the point of the center gauge will be touching on the surface. So you rotate. If you find there is like a gap or the needle's point is not touching the surface, then you again adjust it. Then again you rotate, and you do that until at every angle the needle is touching to the surface of your job. That's
What
right.
in case of a square kind of a job?
In case of square job, then you will touch on the like four edges or corners.
Have you used the scale? Like we put the scale in all the ends of the chuck and we measure the distance, like in mm, 6 mm, 7 mm, and we count in all the four different chucks. Have you done it?
No, actually, this is what I done in my engineering
Yeah,
college.
yeah, yeah. But
Actually, I've been taught it by the instructor rather than the teacher. So he was like, it was a layman method: tap it, adjust it, and see. Just give it a spin and see if it is centered properly.
I
That's
think
how I did it.
this one will not be possible in a like rectangular
Kamlesh, you have
shape
done
job,
only
right?
center this, no? Three-jaw chuck only. You have worked with four-jaw chuck.
No, actually, I've done it mostly on three-jaw chuck, but we had a four-jaw chuck machine, and
Okay.
he showed us how it's done. So
If
that's
it
it.
asks, if it is asked, we can say we never had a four-jaw chuck in our workshop.
Yeah,
Yeah.
but it's good to
Then,
have like some knowledge about it, you know.
yeah, yeah, you should
So
have
if
knowledge.
anyone find it, then just go ahead.
Like
Yes, yes.
yeah, I think let's move ahead. Kamlesh, we have explained like we were discussing parts of a lathe machine.
Okay.
So I think then we went to how to align a tool. First the tool, then the job.
Okay.
So I think three-jaw chuck and four-jaw chuck is completed. And will he explain? Will he ask for the differences or something? Explain what is a three-jaw chuck? We can explain in like everybody can explain in one line, right? Or in IMS, they ask like different type of questions for chuck. Does Avito knows anything? Have you discussed with him?
Are we going to meeting?
No, no, he is not in a meeting. I'm just asking because he had given his interview and he was asked upon late.
I doubt it. I think we should have called him today on the late
Yeah, on the late
discussion.
he was like,
Yeah, he had some practical exposure to that.
yeah,
He would have been best if he was there. And we'll try to continue whatever we have got, and whatever questions left, we'll try to like take them later.
yes, sure. So now I think we can move on to the operations that are performed in a lathe. Who wants to answer the operations that are performed in a lathe? Anybody?
Turning,
Yes, Haris, you can explain.
fishing, chamfering, thread cutting, drilling,
can you explain the turning process, the turning operation?
Turning process is where the workpiece diameter gradually decreases to the specified diameter.
Can you please repeat the answer once again?
Turning process is where the diameter of the workpiece gradually decreases.
Okay. And how is it done?
It is done with the tool.
Like it
The
should
tool
be
is angled at a 45 degrees with the workpiece, and then turning the workpiece starts spinning, and the tool starts machining it.
okay. And would you like to explain the other processes?
Other processes, I don't know like so much.
Okay, all right. So, who wants to explain all the processes that are performed on a lathe machine? Gaurav, will you try?
Yeah,
Yes, please.
testing, turning, taper turning, and parting, chamfering, grooving, uh, drilling, boring, counter boring, counter sinking, and parting, and thread cutting also. That is.
So, first, can you explain the taper turning process?
Yes, taper turning process is the material's diameter will be from low to high. It is gradually increased. That is called the taper turning. Here we require the at first the compound slide at a certain angle as per our required the taper, and we measure that how much distance we require to taper. Then we hit that tool as this direction, and taper will be done over the job.
I think this much is enough, right? We
Understand
don't
you?
need to mention the formula to count the to calculate the angle and all, right, Kamlesh?
No,
Uh,
no. That is
better if you know, but I don't have it to be honest.
I have seen it, but I don't remember it. I also don't
Yeah, exactly.
like I know
It's
it,
better if you remember it, then go ahead. But I don't think they'll go that deep.
maximum time I think we have used 10 degrees. Like
You know how the jobs were done in the
yeah,
engineering. You
yeah,
know the
yeah. It is
angles and
as
all
per
that stuff.
required. It is not. It is as per
Sorry?
It is as per required. You can be
yes, yes,
5 centimeter. You can taper 10 centimeter. You can taper as per
Yeah, yeah,
angle.
yeah.
yes, correct.
Yeah. But for setting that angle in the taper turning gauge, you have to do some calculations with the distance and angle and I think sine or there's something.
Sine
Yes, yes.
10 theta or sine theta. 10 theta
Yes.
is
Before
equal to
calculating,
some.
at first calculate.
That taper. Yes, right. DL by DS,
Yeah,
DL minus DS from L. Okay. So it's basically just a tan formula, I think.
Yeah, 10 theta is equal to, I forgot the whole formula.
Yeah, you like larger diameter minus the smaller diameter divided by the length of the like job. Then
Yeah,
you
yeah,
get offset distance. Okay, I'll share some video about it on the group
yeah.
afterwards.
So, who wants to explain the other processes?
Kamlesh, what's the
Can I
formula?
go?
Can you repeat? Can you repeat, please?
I'll share a detailed video on the group afterwards.
Okay, okay, okay,
Okay.
okay, okay.
So can I go for the operations?
Yeah,
Okay. So first of all, we have turning, then we have taper turning, then we have step turning. In these three options, we are changing the diameter of the job. The tool moves like perpendicular to the axis of lathe. Also, it moves parallel to the axis of lathe. Okay. Then we have drilling operations, where the drilling bit is mounted on the dead end of the lathe machine, and we gradually insert it, like advance it towards the job, and drilling is performed. Similarly, we perform boring operations, uh, then reaming operations. After that, we have knurling operation also there. Knurling tool is there. It like creates texture. Like you must have seen that on the handlebars. So the process is called knurling. We use knurling tool for creating that. Uh, then we have thread cutting operations. So using lead screw, we can cut threads on the job.
Like, all the functions are mentioned, grooving or parting off. You mentioned it, right?
Yeah, grooving and parting, these operations.
So if they're going to ask this question first, you should think name them, right? Then explain. He will, I think, cross
Yeah, yeah,
question.
exactly. If he's asking for he won't ask for all the operations. He'll just pick one out of them, and he'll be like, okay, great. Most probably he'll be asked about taper turning or thread cutting operations, because these two are a bit complicated ones.
And chamfering is also a type of taper turning, correct?
What?
Chamfering.
Chamfering is just you round off the edges.
Edges, yeah.
Yeah, it won't be actually in the taper turning process. You just do it eyeballing for like 45-degree turn. If it is very specific, then you can do it by taper operation also.
Okay. So anybody wants to explain all the processes, how it's done?
All the processes.
Yeah. Like,
Just a minute. Okay. So I think we have gone through the turning and taper turning and
yes.
step turning, these three operations. Okay. Then I'll come to the drilling and boring part. So drilling is operation where you drill a hole inside your job. Your drill bit is mounted on the dead end of your lathe machine, and your job is rotating. You slowly advance your drill bit towards the job, and it starts penetrating. You provide lube or your circulant if required. Boring is the operation where you enlarge the diameter of the already existing hole. Okay, it is similarly done. The what is it called? The boring tool will be attached on the dead end, and the job will be rotating. Uh, in the knurling operation, we have a special tool, knurling tool, which is mounted on the tool holder, which is so we just push it against the job, and it gives the check pattern on the surface of the job. It has two wheels on which you can find that slanted edges like texture.
Diamond
So
shaped,
yeah, diamond shaped
diamond
texture.
shaped it is. So
Uh, yeah, go
like
ahead.
while you were working, do you remember that? What were you using the tool, the knurling tool? It had 6 different
Mhm.
rollers or just 2 rollers?
Uh, in our college, we have two roller wala stuff, that
2
small tool.
rollers. Okay.
Yeah,
Yes, Guru.
Uh, what, Gaurav?
and about thread cutting, I cannot explain it properly because I haven't prepared proper answer for thread cutting, but I'll share it afterwards.
All right. Okay. Anybody?
Okay. Then fetching operation is there.
Yeah.
I forgot.
Yeah.
Fetching operation is there. Fetching is when you just uh, level the surface. You move your tool towards the center of your job and make a clean cut on the end of your job.
Okay. And in grooving and parting off, if we need to do grooving, then we bring the tool post at the location of the job where we want to groove it, right?
Yeah.
Then we
And
start rotating the spindle,
yes,
and
to
when
we start to advance it
with
towards
the
the axis.
with our own hand like handle in the compound slide, right?
Yeah,
We
yeah,
need to
yeah,
rotate
yeah.
it, correct?
Like
So if we need to do parting off, then we will just make the groove bigger, correct? And
Yeah,
then
yeah,
we'll go
we'll
deep.
make it true.
Yeah, that we'll just we'll just increase the length of the groove, then we'll just go in and just part it off, correct?
Right.
So,
Unless you know about the axis, which one is the what axis? Like axis of the spindle is the x-axis, correct? Is it tx? Like lathe has a axis, no, x, y, and z. So which is the x?
It's yeah, just standard geometry. The lathe is X, then
Okay.
vertically, I think vertical we take as Y, and this one is Z.
Z. So there won't be any yeah, y will be there, yeah. Tool for the tool, no? Height for
Yeah,
the
yeah.
tool
So
height.
see, when we are talking about the axis of lathe now, then what I think is it's mostly about the axis of your what do you call it, chuck and the dead end. You know, the imaginary line passes between these 2 points. So you don't have to bother much about that X and Y and Z axis. So mainly it's about the axis of rotation of your tool.
Okay, okay.
to align the chuck with the spindle, we just need to compare the numbers, right? There are numbers written in the
Uh,
spindle, there are numbers written in the chuck, like 1, 2, 3. Then just use it
Yes, yes, to give the feed and all.
to
One
give
is
the
used to give the feed. Like if you say you are doing facing, no, so the feed will be given like in the negative x direction. That means in the along the axis of rotation in the negative x direction. So you rotate the wheel like you giving like two steps. Like in the first case, you give a two degrees rotation or some between some this. So like say 30, 31, 32. You give a feed, and then you rotate the a job in the positive z direction. So that is how the facing is done.
so in the testimonial, IMS testimonial, is there any other questions regarding lathe machine? Yeah, how to stop a lathe machine during emergency?
it is skill switch, right?
At the bottom of the lathe machine, there's that lever, right? We just need to use one leg and
Mushroom type of lever,
pressure.
yeah.
Yeah, yeah, yeah.
Yeah,
That is it, right?
guiding.
Foot brake.
What's the
Foot
name?
brake.
Foot brake. Okay, okay,
They are already fitted foot brake.
okay.
Okay.
So there's nothing else, right? Just the foot brake. We need to pressure the foot brake and that's it, correct?
One is foot brake and another is the emergency stop button.
Yeah, I
That is
think
over
it's
fitted
called
over
as
the head stop.
skill switch, right?
What?
Yeah.
The another thing is that you kill switch is there on the to stop the motor in the emergency, right? You hit
Yes.
the kill switch, the motor
Yes. Yes.
shut
Yes.
off, and then you hit the foot brake.
Yes.
Okay. So we need to hit both, like the emergency that kill switch and the brake too, or just one will do the work.
To be honest, I'm not an expert in this.
Gaurav, do you know it?
Anyone. You can use
Anyone?
the
Okay,
foot
okay,
brake.
all right.
Anyone you can use. You use the foot brake also, but you can use the kill switch
Okay,
also.
all right.
I think
In the
when you are
emergency position, which is your mind will be work. Yeah. Tell.
Octavio, are
if
you
you are
saying something?
closer to the if you are closer to the foot brake, then you should apply that because the emergency button is on the other side sometimes
Yes.
while working.
Okay,
Yes. Yes.
so that's
That
the
is.
reason why the uh, brake is given, right? That lever at the bottom is given. So if you are not able
Okay.
to reach to the kill switch, then just press it. Kamlesh, do you have any other questions regarding lathe?
Um, no. Can anyone explain the thread cutting operation? If anyone has any idea, brief idea about it, or have you covered it already?
No, we have actually not covered it fully. Just one. Somebody have just mentioned the thread cutting operation, but not
Okay.
explained it.
I think it will be an important because
Yes,
this is one of the complicated, sorry, somewhat complicated on the machine. So this operation
like
must
I
be.
will just try to. I don't have much idea, but just I will Just correct me if
Mhm.
I'm wrong. So we use a V-shape tool, right? Cutter. We fit it in the tool
Okay.
post, and then first, then we engage the lead screw.
Okay.
Then auto fit is given. First we measure. First we align the tool with the chuck tool, with the job tool. Then we engage the lead screw, and then when the feed is given, first a line is drawn. First cut is given, and when the whole
Okay.
first cut is given, it is not too deep, just a line, just a circular line. And then after second, like second, third, fourth, fifth, we go a little bit deep, 10 deep, 10 deep, and at the finishing we don't, at the last, like after 5 6 cuts, we don't go deep, just the last one is just for finishing, so that
Okay.
it becomes smooth. And we all, and after cutting the threads, we can also use this one, what's the paper called, to smoothen the threads.
Five? No.
I just forgot the name. Filing. We can do filing in the threads too, so that the
Okay.
it can become smooth. So I just know
Okay.
this much. First, we always
That
need to
is
give a
not
line.
required. That is required.
Then, Gaurav.
Sorry, you want this?
Can I explain
Yeah,
from
please.
first?
Yeah, yeah, go ahead. Go ahead.
Uh, At first, we fitted the workpiece and job will be true. Then we first doing the champering. Small champering will be at first done. Then we will fix the. There are already a given chart for the pitch diameter between the gap of the every teeth. That is called the pitch diameter, and that is already given by the manufacturer of the lathe. Here also a chart, and as per required the chart, there are three measurement gear will be present. That will be engaging there at first. Then the lead screw will be engaged. Lead screw then start the with respect to the spindle RPM, means spindle will be rotated 500 RPM, and we require the 2 millimeter gap between the pitch. Then we require this more speed than the spindle of the chuck, a lead screw. Then the carriage will be more fast. Understand?
Mhm.
Hello.
Yeah.
Yeah. Hello.
Then that's why we require the more fast. Uh, yes, I will tell you. And then we engage the lead screw. Lead screw then start to rotate with the carriage a fixed RPM with respect to the spindle, and then it will be we are giving the feet as per required how much deep you will require the thread. Then that thread cutting will be operated. That is, and we not require the. I think we not require the filing process, because where the precision will become between the we cannot be filed between the thread, it can be damage the thread.
Okay.
Okay. I
I've
think
seen
I
people filing at last,
at
but
last, yeah,
some
yeah.
minute. Yeah, yeah, I've seen
But
filing.
I don't know. I'm not sure in which thread. That was which thread while cutting after finishing. It was filing. I forgot the name.
Okay, because some kind of blurs come outside, no?
Yes,
So you
correct.
file it.
Yeah, filing is done at the finishing. But Gaurav, I didn't got the
You
starting part.
understand what
Yes,
Yeah,
yes.
yeah, yeah.
I got the
at
explanation.
first?
At first,
Gaurav
the
is champion in lathe, I guess.
No. That is not. At first, we record the champering because of the at first when we give the uh, uh, means the cutter means the tool.
yeah.
When we tool will be fitted as a when we give in the job, it is a high stress will be create on the single point cutting tool. That why it can be broke. That's why we need a champering for fixed. Every knot you will see at the bottom side of the at the starting side of the thread, a champering will be done. That is the
Okay.
reason for the champering. Yeah.
Okay. I thought the champering is done after the completing the operation. Then we just need to smooth down the edges, right? Okay.
Exactly. That's what
Yes.
I thought.
Yeah,
But
No,
it's
no,
important and it makes sense.
makes sense. Yeah.
no. Champering.
Correct.
First champering, then we start the job.
Okay. Okay. So after sampling, you were explaining some. What was the calculation thing? Do you know, Kamlesh? I don't know the.
Yes.
Uh,
And
Anyone are not understand and
No,
please
we
ask
got the
the question.
explanation.
I will
Yeah.
elaborate
We
that.
got the process, but
We
if you
got the
have
process.
anything on detail, then please go ahead.
Means,
Like
yes,
the calculation
yes,
part. I
I will
didn't got
give
the
the
calculation
when
part.
you require the yes, you require the 2.5 mm pitch diameter between the two thread, or another one threading operation you require the 3 mm
Is it same for all threads?
can be done.
2 mm or 3
Continuous
mm?
feed rod.
Pitch
No.
is
As
no
per
pitch is
required,
basically
that
It depends on the lead screw too, right?
pitch is basically like distance
yeah,
covered.
it will,
Yeah,
The advancement of a screw
yep,
during the one rotation.
yeah.
No, pitch is the distance
means
between the consecutive crest
can
or
I
tip,
cannot
correct?
I
Whether
Yeah.
cannot
Sorry.
explain
Sorry.
it
Sorry.
with my mouth.
it's all right, it's all right. We are getting it. So,
Because the thread in between the thread we already given take a gap, that is the thread teeth. Now, when we give the continuous feed, this thread teeth will not be created over here. That's why we would require a distance, gap distance between the every thread, and that this thread distance always be created by the gear mechanism, which will be predetermined by the company. Company gear mechanism will be fitted over the lathe. That is as per required. We will connecting this position of the gear, and this gear will be engaged, and the lead screw will be run that RPM with respect to spindle. When we require the 2 millimeter diameter between them, then we require the spindle will be rotate 500 rpm, and the lead screw will also rotate the 1000 rpm. Then we get the between them the 2 gap. Understand?
yep, yes. Can anybody tell me what are the like lead screw is required in which functions, in which operations? I think thread cutting and
Lead screw is only required for the threading purpose. Yes,
only
only
thread
threading
cutting.
purpose.
Okay.
Only thread cutting purpose.
It can be also used for turning, no? Like if you want a uniform, like kind of this, you can
No, no,
even use
yeah,
it for
sorry, sorry,
turning.
sorry, sorry. That is
Actually,
my
it used for actuating the
sorry.
carriage.
That is my mistake.
It is actually
Feed
used
rod.
for actuating the carriage.
Feed rod is used only for
Yeah,
yes.
tell.
Feed rod is only used for the thread cutting, and the lead screw will already used for the continuous feed. Sorry, that
So,
is my mistake.
what
Is
is
it
the
I will
feed?
already mixing up
is it
all
feed
the
rod
time.
or lead screw? I'm getting confused.
What is the function of the feed rod then? The carriage moves on the feed
Feed
rod
rod, yeah.
manually. Is it Gaurav?
Yeah, feed rod when we require the continuous feed means the feed rod RPM and the spindle RPM always the same. Then we give the when
No,
the
feed rod
spindle will
doesn't
be
move, no?
rotated
No. Wait,
means as a
wait. Feed rod doesn't rotate, right? It is stationary.
feed rod also rotate. Feed rod also rotate when we engaging the gear of the feed rod. Then we engaging the hub nut. Then the carriage will be attached with the feed rod,
It is with the
and
lead screw,
carriage
no?
gets
Half
a
nut is with
motion
the
of the linear motion with left or right.
Kamlesh.
Hub nut fitted over the carriage.
I'm always confused while feed rod and lead screw. Can anybody explain like easily?
As
Kamlesh?
of what I know,
Yeah.
the yeah,
Can
Kamlesh, is it the feed rod rotates or is it stationary?
Uh, I, to be honest, I don't have exact idea about how thread cutting is done in lathe. I actually have left that question afterwards,
Okay.
but I'll try to find something. As far as I remember, feed rod is just it's not rotating thing, but still I'll just go through it once and post update in the
Yeah, for
next
the
session or on the group.
as of what I know, for the constant feed, use a lead nut wherein the half nut on the carriage engages with the lead screw and then you get a feed, like constant feed. While
Okay.
feed rod is just screwed for moving the carriage onto the lathe bed, like
yes.
from the positive to the negative axis.
I also
Is
think
it
that.
Gaurav?
I also think that depth is the concept. But I'm confused on when the
Yeah.
Is it correct what I said, Gaurav?
Yes. One time the question, please. Yeah, I not audible. I not listen your. What are you told? Please tell me one time.
So I said the lead screw
Hello.
is like it is used for giving. You can hear, Gaurav?
Gaurav, are you listening?
Yeah.
Okay, so I said the lead
Yeah.
screw is
Yeah.
used only for a constant field. Like if you want to move the carriage with the constant field, like say for the thread
Please
cutting.
always
So
remember.
yeah,
Yeah.
can't hear you, Gaurav.
Yeah.
Gaurav,
Feed
you are
rod.
not audible.
Yeah. Hello.
Yeah,
Yeah, yeah.
Hello.
yes.
Yeah. Feed rod always used for the thread cutting purpose for giving a continuous speed with respect to spindle.
No, it is lead
Feed.
screw, no, not feed rod, Gaurav.
Continuous speed.
Lead screw, no.
Feed rod is giving the continuous. Feed rod क्या करते हैं? Means I will tell you the when we thread cutting, the one will be grouped and another one will be spiked.
Yeah,
Yeah.
yeah,
In the thread you will see the one is grouped and another is spiked.
yeah, yeah. The
That
tie
is called
rod
the
is
thread.
like
The where come the this gap between them?
can't hear
When we
you.
give the continuous speed, I always the cut of the this spike. Understand? That's why we require a jumping or the gap between the rotation. It will rotate the 500 rpm, then it will go rotate more than this speed. That is a gear mechanism will be fitted over there. I not the know the that is the what mechanism will be fitted. That is already know the manufacturer who will be create there that there. Like indexing where we are using the milling machine indexing. This is the same process. We will not know that. As per
And
required, that is a calculation already predetermined by the manufacturer.
I
okay,
just saw on Chat GPT that is it the feed rod that rotates? It is saying feed rod doesn't rotate. It's the lead screw that rotates. Okay, I think
Guys, how about we like go through the topic again and share some like valid material on the group afterwards? And for like time being, let's move on to the next
let's
yeah,
question.
yeah.
move on to
Let's
the
move
next
on. Like
question. Yeah, yeah.
okay,
And
Yeah,
if anybody will find any good videos, please share it in the group.
yeah,
So we already explained what is pitch, right? So
yes.
I think lathe is completed, correct?
Let's see what.
Yeah,
What does they mean by lathe machines cross question?
Yeah, cross questions. I added one or two questions like how is the job aligned, about the center gauge, about the dial indicator, and also the tool
yes,
post.
I will tell you something that
Yeah, Gaurav, if you have any cross questions, please.
here is liquid coolant used on the machine. Yes, there can be asked the which liquid will be used for the cooling purpose of the lathe machining.
What
Do
was
you
the
have
name?
any idea about it?
I have seen this question. I don't remember in which interview, but I have seen in much in our decoded banner that this question was asked. This name was, I think it was in MSc or Synergy, the name of the refrigerant. Gaurav, do you know it? I'm trying to get an answer.
That is a mixed liquid will be fitted as per required. Which machining will be done over there as per required. There are two, three types of coolant. The different temperature control as per required the material where the friction will be more. I don't know the name of the proper thing of the different type, but that is you can tell that is enough.
Okay.
Okay, while milling, drilling, tapping, and turning, a soluble oil coolant is used, which has 70 to 90% of water to oil ratio. So I think it's a mixture. Yeah.
That is as per required. You can make this liquid coolant as per
Okay.
required of the material which will be machining over here.
Okay. So any other questions? Do you have any other questions regarding this? What is speech? We already completed that part.
Yeah, another I will give something some questions
Yes, please.
like how you make the single point cutting tool. It can be asked.
Okay, the tool.
It can be asked because when you record the thread cutting, required angle will be required between the thread. We will grinding at first. as a single point cutting tool, and we will measure that thing with a angle gauge, which will be thread angle gauge. By the help of thread angle gauge, we will measure that. Yeah, that this type of question can be asked as a cross question. Others nothing.
Okay.
Or
Okay. The tool we
which
use
material will be
to make sure
used for?
that. Hello.
Yeah, yes, Kamlesh.
Yeah, Gaurav, are you talking about that
Yes, yes.
like gauge tool we use for making sure that our cutting tool is perpendicular to the job?
That is center gauge, right?
No, no, no,
Yeah,
no, not thread cutting.
perpendicular.
In the thread cutting operation. Wait,
Okay, got it. To measure the angle of
I
the
can't
threads, right?
understand your question.
are you talking about the tool which we use to make sure our like, cutting tool is
Can you?
perpendicular to the like job? This one.
Gaurav, you are not
Yes,
audible, I
that is
think.
the process when we fitted.
Yes, now you can speak. Sorry.
We will fitted the job will be true. Yes, this tool and the we are gauge will be already perpendicularly fixed.
Are you talking about this?
Yeah. That is
Okay.
bro.
What's the name of this thing?
Good. I think it's the thread gauge angle or something.
Angle
Thread angle
gauge.
gauge.
Angle gauge.
Thread angle
Wait,
gauge.
wait. Thread
Thread
gauge.
angle gauge.
What?
Thread gauge or thread angle gauge.
Thread angle gauge. Okay,
Yeah, thread gauge. Yeah, thread angle.
okay. So I think late is completed, right?
Yeah.
Have I stopped sharing?
Huh?
Have I stopped sharing? Yeah. Okay.
Yeah, you have stopped sharing. So, Kamlesh, do you have any other questions
Just
regarding lathe?
uh, let's no, no,
Okay.
no.
So let's just complete lathe, then move on to the further questions.
Have we completed like types of thread?
No, now the next part we can complete threads. Lathe is completed.
Okay.
No, now the types
Okay.
of threads. Okay, I'll just stop this video.